Virtual Shaker is a plugin for CATIA. With it, an engineer is able to simulate the vibration tests which are performed on the Shaker table. It also offers additional tools for different vibration loading scenarios. In the next few minutes, we will present the basic functionality of the simulation package and guide you through an example. Virtual Shaker is seamlessly integrated into the standard numerical analysis in CATIA and is used to estimate time to failure of the finite element model without leaving the CATIA environment. The real vibration test on the Shaker table requires a prototype to be built. This is expensive and time-consuming. On the other hand, the analysis with the Virtual Shaker is fast and can be used numerous times during the design process. This way, one can avoid unexpected fatigue failures and compare different designs in respect to the fatigue criteria. Before the Virtual Shaker is run successfully, some initial information is required. First is the validated structural model, which is usually already built at this point. The material fatigue parameters are needed next, which can be obtained from the supplier or measured by the experiment. Finally, the type of loading to apply must be known. This can be a sine sweep, a sine dwell, or a wideband random process. Each type of loading needs additional parameters before it is fully defined. The random loading, for example, must be defined with the frequency profile like the one in the vibration test specifications. Based on the supplied data, the Virtual Shaker gives time to failure estimate. The following is an example of the fatigue analysis procedure in Virtual Shaker. The process begins with modal analysis, which exposes the vibrating mode shapes, like for the sample assembly pictured here. Virtual Shaker is now run by clicking the toolbar button. User must define the nodes which will be excited and areas of the model where the time to failure will be estimated. Material parameters are set and damping, if known, can be passed to the Virtual Shaker. The load is chosen and additional parameters are set, depending on the type of the loading. Virtual Shaker offers different calculation methods to choose from, and optimal methods can always be set automatically. Very fast frequency domain methods are available, and when exceptional accuracy is needed, one can also use the conventional time domain methods, which is computationally more intensive. When all the parameters are set, the simulation can be run. Let us now observe a simple demonstration of fatigue analysis performed with the Virtual Shaker. After the calculation is concluded, the results are immediately available inside CATIA. The design process can now be continued with the knowledge of critical fatigue points and expected time to failure of the assembly.